First of all, what is the Stokes law? What for this is Stokes law? Is the point. Let me explain first, right? So let us consider a fluid. You know, a fluid always moves like different sets of layers. Each layer, while moving in one direction, oppose the motion of the other layers. Thus, it develops a kind of a relative opposition, which is called something like viscosity, similar to kind of the friction in the solids. So, this is a fluid with different layers, and these different layers are having that kind of a viscous force inside. Let's imagine you are having a solid material in it, and that solid material is moving. So, because of that relative motion, this solid layer also experience some opposition to its motion, some opposition force to it. How much is that opposition force is? How much is that viscous force that it experience? So, viscous force experienced by solid, while it is in moving with a fluid, is found, it is identified with a law called something like Stokes law. So let me repeat by telling you that Stokes law tells you how much is the viscous force experienced by a solid while it is moving in a fluid, where the fluid is having some viscous force. So it is experimentally observed that solid experience a viscous force that depends on the things like size of that solid, shape of that solid, then depends on the nature of the fluid, depends on the nature of the fluid, and it also depends on velocity of that solid that is moving, and also depends on nature of the fluid. So viscous force experienced by a solid depends on three factors. That's the size and shape, which is measured here under observation as the radius of that solid material. Nature of the fluid is measured with a term called coefficient of viscosity. Velocity of the solid is rate of change of displacement, V. So these three factors it depends on. By what factor, by what dimension it depends, we can identify using dimensional analysis that we have learned in the first chapter itself. It's very simple. So what we say here is the viscous force that's experienced by solid depends on radius of that solid material by unknown dimension by 1, 2 or minus 1, I don't know, therefore power A unknown, I have to identify. Velocity of the fluid by again unknown dimensions B, and then nature of the fluid is with coefficient of viscosity C. That proportionality can be eliminated by keeping a constant K, proportionality constant, which don't have any units and dimensions. Radius power A, velocity power B, coefficient of viscosity power C. Now, to identify what is Stokes law, I shall know what's the value of this A, what's the value of this B, and value of that value of C. That we can identify, as I said, using dimensional analysis called and a concept called principle of homogeneity. What is that principle of homogeneity says? In any right physics equation, dimensions of left hand side of the equation is the dimensions of the right hand side of the equation. That means the fundamental physical quantities will have identical dimensions in a given physics equation. That's the basic concept that we have learned earlier. We have discussed it in depth in that chapter. You can refer there. But now my job is to find out the values of A, B, and C. Before that, I shall know what's the dimension of radius, velocity, and coefficient of viscosity. Let me find that out first for you. Radius is nothing but length, so it has a dimension of only length. Velocity is a dimension of rate of change of displacement, LT power minus 1. I don't know whether you remember coefficient of viscosity. That's why I will just derive that for you quickly. If you know that, you can skip this part. So what is that coefficient of viscosity? It tells you. Viscous force is directly proportional to, we have discussed this earlier, area of the cross section of the fluid difference between the velocity of the layers, and inversely proportional to the distance between the layers, right? So we can eliminate the proportionality, we can put a constant, and that constant is just a second. That constant is coefficient of viscosity A dV by dx. So I'm trying to find the dimensions of that eta itself for you. We know the formula for the viscous forces, and if force as ml to power minus 2 eta I want to find out. Area is L square. Change in velocity L t power minus 1. Dx is length L. So this L and L will cancel. So for eta ml t power minus 2 by L square, and this t power minus 1 will come to the denominator. So what is its dimension? M L power plus 1 and minus 2 becomes L power minus 1, t power minus 2, and it becomes plus 1, that is t power minus 1. So I have quickly identified the dimensions of coefficient of viscosity, which I will use here in this equation, right? Let me go back to the basic equation that we are talking about, this equation. Yes. So, viscous force experienced by a solid is constant. We need not worry dimensionally. Radius, that is L power A. Velocity of the solid, Lt power minus 1 power of the B. Coefficient of viscosity we have just now discussed, ml power minus 1, t power minus 1, whole power of C. So force has the dimensions I know. Mass into acceleration, ml t power minus 2. I am not writing k because it's dimensionless. Or else let me write, no problem. L power of A, Lt power minus power of B, m. This is coefficient of viscosity, power of C. Let me equate the dimensions of mass first on both left hand side and right hand side. On left hand side, we have dimensions of m power 1. On right hand side, you have dimensions of m power c. So equating dimensions of mass, 1 here, c here, nothing else. So I straight away got a value of c is equal to 1. Let me equate the dimensions of length. Left hand side, dimension is only 1. Right hand side, L power is A is the dimension. L power of B is also dimension. I am equating dimensions plus B. This is minus C. Minus 1 and C. But I already found that C value as 1. So A plus B minus 1 is 1. So A plus B equal to 2. I got an equation. I will use this equation later. Let me just remember this equation. A plus B equal to 2. Now, let me equate the dimensions of time. Here on the left hand side, time has a dimension of minus 2. Here minus 1 into B, that is minus B. Here minus 1 into C, that is minus C. Right? Then, but I know the value of the C already, that is equal to 1. So minus B minus 1 equal to minus 2. That implies minus B minus 2. Minus 1 becomes plus 1 this side. So minus B equal to minus 1. So B is also equal to 1. I found one more value. B is equal to 1. Now let me use this equation that we have derived already. A plus B equal to 2, but I found B value as 1. So A is 2 minus 1, that is equal to 1. So if you observe carefully, I found the value of C, I found the value of B, I found the value of A. Let me substitute all of them in the core equation we have discussed. This is the equation that we have been talking about. So what is that? What it will happen then? Viscous force by a solid is some constant K, R is radius, power of A, we have found the value of A as 1. V is velocity, power of the B value also we have found as 1. Coefficient of viscosity, power of C value also we have found it as 1. So this proportionality constant cannot be found dimensionally. By experimental observation, it is found that value is 6 pi eta RV. is the force experienced by a solid when it is moving in a fluid where r is the radius of that solid and v is the velocity of the fluid. This is explained by a scientist Stroke. That's why this law is called as Stokes law. So we have quickly discussed what is Stokes law, and within the Stokes law we have identified on what factors this viscous force of a solid depends on. It depends on its velocity, its size, that's radius, and of course the nature of the fluid, coefficient of viscosity. That's it. Thank you for watching.